Okay guys, welcome back to Bandit level 6. Let's get into this one quite quickly as I think it will be slightly longer than the Interestingly, my headset decided to shut off there. Cool, so we are logged in. Let's clear that message. Let's print our working directory, make sure we're in the right place. We are. Cool, so let's read our brief. Somewhere on the server, there's a file, and it's owned by user Bandit7, who is in the group owned by Bandit 6, and it's 33 bytes in size. So if you've done the challenge before this, you know that find is our good friend here. Now I'm not going to go through the manual with you to show you the headers that we need for find, but I will assume you've read it as well. So we are going to use the user option. The user is Bandit 7. Next argument, we are going to use the group header. All of these are pretty intuitive so far, and owned by group Bandit 6. And next argument is going to be our size argument, and it is 33 bytes in size, so we use C to denote bytes. Let's see what we get. And nothing. Brilliant. Why is that the case? Because, as you'll notice up here, when I listed the files in the current directory, there were none. Now, if you remember from the last video, find without a option, without giving an option at the beginning to denote where it should start from, will always start from the current directory. However, our brief says that it's somewhere on the server, not in our current directory. So we need to tell we need to tell find that it is starting from root. Now root, if you don't know, is like the base uh, the base system, the base directory. There we go, there's the word. The base directory. So we're telling the find command to start right at the very beginning. And it will return anything to us that matches these three criteria. Cool. A whole bunch of stuff here. Loads of stuff. Loads of stuff that we're not allowed to look at. Loads of stuff that, you know, couldn't even find the file or directory that it was referring to when it tried to follow the link and apply the criteria. If you look through here, you will find the thing that we're looking for. Okay? So if you're just watching this tutorial because you want the password and like that's it, then you can just do cat. Well, let's just copy and paste it. You can just cat that. You can grab that, and there's your password. But say instead of this returning, you know, 2 scrolls worth of error messages, it returned like 150 scrolls worth, and the password that we were looking for wasn't conveniently located directly within our view. Let's say that the password was located somewhere in the middle of 10,000 files that were returned to us. We are going to have to get a bit more creative with our command. So, for those of you who just want the password, there it is. Move on if you didn't enjoy this challenge. You know, hopefully challenge 7 is for you. But for those of you who want to learn how to craft this command in a slightly better way, I have 2 versions for you that might help. One of the versions involves piping. Piping is where we take the output of one command, so we take the output of this find command, which we can see here. So this is the output, right? All of this information here gets piped into another command. And this command is grep, which stands for global something, I forget. But grep effectively searches through the output of find to match the output to a criteria that we give grep. So it's very much like find, but it can eat the output of find and search through this massive pile of data that we give it. So let's take a look at the manual for grep. So basically grep takes an option and a pattern and looks through it. So interpret patterns as fixed strings, not regular expressions. Alright, so let's pipe this into grep, and we are looking for the word password in quotation marks. Oh look, it's highlighted it in red for us. There's password. Okay, let's say that this output was even more massive, right? And that highlighting the word that we were looking for in red wouldn't help us, or maybe we don't know that we're looking for a password. We know that we're looking for a password as an end result, but it's quite lucky that this file was called Bandit 7 password. It could just be called a random assortment of strings. But we do know that we can filter out all of those things that we don't want to see have a couple of things in common. One, they all have permission denied, or two, they all have no such file or directory at the end of them. So we are going to run into another problem here, but we'll let that take its course. Okay, so let's say we want to look for the inverse. So in grep, we use the -v string to look for the inverse of something. So that means instead of highlighting red the thing that you've matched, it says don't even bother returning to me anything that matches this. So it's like the exclamation point that we used in find. It excludes it from our search parameters. So let's say we don't want to see anything that contains the words permission denied. And this is case sensitive. If you didn't want it to be case sensitive, you can use the -i flag, but in this case I'm pretty confident that I can spell everything correctly with the right cases. So this is when I spell something wrong, isn't it? Okay, permission denied. So we're giving grep the output of find. We're telling it to withhold from us anything that matches this string, permission denied. Now here it still returned these things to us. It still returned this file, for example, and it clearly says permission denied there, even though we asked it not to in our command. That is because this is not considered part of the standard output. This is not considered part of the file name. So we're asking grep to search through the output of find. Now the output of find is just these. It's just these within the quotation marks here. The permission denied is for us. It's for the user of the program. It's what is called standard error. So this is to indicate to us that something went wrong when trying to access this file. So this is the data that was recovered in the find, and this is the data that we're asking grep to search through. This, permission denied, the standard error, is for us. So when we are asking it to filter out permission denied, it can't even read this, it can't even see it. So what we're going to have to do is a little bit of sneaky redirection. So we know that if you read the bash manual, which is a crazy thing to say, but if you read the part of the bash manual that's relevant to this, you'll see that file denotation as number 2 stands in shorthand for standard error. So we're saying take all of the standard error, take all of these, and redirect them to all of the standard outputs. So we're saying make this something that grep can actually read. Make this viewable to grep. Now there's one more thing we need to add into this small appendment of the command, and that's an and symbol. This just denotes to the shell that 1 isn't the name of a file. we're saying this is 1 as in the shorthand for standard output. So we're saying take all of the standard error messages that we would get, all the permission denied, give it to standard output. So that should mean that instead of grep only being able to read this, grep could now read this, which means, as an extension, that grep should now be able to filter out all of those files that end in permission denied, because it can now see them. So we shouldn't see anything with permission denied. Amazing. So we've cut down our search massively here. But we are still left with the no such files or directories. Again, we can still see our password here. If you've stuck around this long, I assume you want to see this all the way through to the end. So how do we get grep to filter out not just the ones that say permission denied, but also the ones that say no such file or directory? Well, we do that with the E flag. E literally just tells grep, hey, I've got more than one pattern for you to recognize. So when grep reads E, it will know that there's not just permission denied that we're looking out for to exclude, there's also another one here, which is no such file or directory. If you read any of these, do not include them, as we've told it to here with the V. Cool. So just to summarize this entire command so you know what's going on, we've taken the find command, we've told it to start at the root. Our first flag is for Bandit 7, the user. Our second flag is for group, which is Bandit 6. Our third flag is to find return files of a 33 byte size. Then we've taken the standard error messages and we've passed them to standard output, which means that the result of find can now be piped into grep, which will only return those file names which do not match the following patterns. So it will only be returned to us if it does not match permission denied or no such file or directory. And there we have just the password. And by filtering out those things that the unwanted file names had in common, we are left with only the wanted file name. So if you stuck around for that exceptionally long video, thank you, and I will see you on the next one. Oh, hold on a moment. For those of you who've stayed around, you should at least get the reward of reading the password one more time. We use copy and paste and cat, and there it is. There's our password. Control C to copy that and exit to sever our connection. Thank you for sticking around.